Right, guys. Let me open the content.
Good morning, sir.
Very good morning. See, how many layers are there? 7 layers are there. Okay, cables works under layer 1. The cables will understand only signals. And switches are the layer 2 devices. They will understand layer 2 address called MAC address. And routers and L3 switches are works under layer 3. They will understand layer 3 address called IP address. And firewall is a multi-layer device. Most probably at layer 4, it can able to filter TCP or UDP related services. Okay. What will happen in the presentation layer? Encryption, decryption, encoding, decoding, and data formats will be defined in this layer. What about the section layer? It will create a section, maintain the section, and terminate the section. Application layer, browsers will come. What are the requirements? Without browser, we can't access. And also, browsers are just only interface only between you and your servers. But what are the background protocol to fetch that web page or mail page? Mails or these things, protocols are required. For web requirement, what protocol is the background protocol? HTTP and HTTPS. Clear now? For any requirement, there are some background protocols will be there. Okay. Those protocols also works under application layer. Whatever the PDUs at layer 7 to layer 5 data. That means it could be web data, mail data like that. Okay. Or else HTTP data for web. Whatever the SMTP for mail like that. Okay. And data once it will come. That means we are uploading some data files. That file is called one data. The data will be converted into small segments at layer 4 by means of TCP. That's why that is called TCP segments. Then the TCP UDP both are entered to the IP box. That's why that is called what? IP packet. That means at layer 3 we are adding the source and destination IP address. At layer 2 source and destination MAC address by means of Ethernet protocol. At layer 4 we are adding the what it will enable TCP, and it will carry the higher layer information. That means any service. That means TCP will define the source and destination port number also. Will define the source and destination port number. Based on the destination port number only, the device server can understand this is related to this port number is related to this protocol. By using that protocol only, it can able to open the web page. Clear now? Right. How many total ports are there? The port number is required to identify the particular services. Based on the port number only, device can respond. Server can respond. Okay. Maybe you are asking about the web requirement or mail or file. Okay. Now, what are the reserved ports? Up to 1023. Remaining all are what? Open ports. Okay. Let me open next one. Yeah, TCP and UDP difference we need to discuss now. And before discussing, the major topic is yeah, this one. Please write down this one: encapsulation and decapsulation. This is very important. Okay, encapsulation and decapsulation. Encapsulation means what? Adding the headers. Headers means, what do you mean by header? Header means information. At layer 7, what it will add? Layer 7 protocol. Correct. Now we are not typing this one. At layer 4, it will add the layer 4 information. At layer 3, it will add the layer 3 information. At layer 2, it will add the layer 2 information. That is called adding the headers. From where to where? Layer 7 to layer 1. Correct. At layer 7, it is adding the layer 7 protocol. At layer 4, it adds in layer 4 information. At layer 3, source and destination IP. At layer 2, MAC address. Okay. And see, in the this is called totally Ethernet frame now. Clear? Totally what? Ethernet frame. This is totally nothing but what? Ethernet frame. Now in the Ethernet frame, see, MAC address will be how many bits? 48 bits in binary. In byte and how many bytes? 48 by 8 now. You will get the 6 bytes. That means in the Ethernet to frame consists of every field in the form of bytes only. Every field in the form of bytes only. But bytes your cable will not carry. Will carry? No, it will carry only bits only. The bytes will be converted into bits with the help of your LAN card. Clear? Your device as a LAN card that will convert from bytes to bits. That means bytes means Ethernet frame. In the Ethernet frame, every field in the form of bytes. That means you understand simply Ethernet frame to bits. Okay, done by the LAN card. Then bits this cable will carry. Correct? Na? Correct? Na? Up to this process, understand? That means before sending via this cable, we need to convert into bits. That means once you type this requirement, what is your requirement? Your requirement is this one only. Then automatically what will happen? At layer 7, this will be added now. We are not adding this one. Okay. At layer 4, TCP is adding. At layer 3, IP is adding. At layer 2, this one. Okay. Now, this is totally nothing but at layer 2. What is the PD for layer 2? Ethernet frame. Okay. Ethernet frame will be always every field in the form of bytes. That should be converted into bits done by the LAN card. Then cable will carry the bits and it will come to the bits. Again, this LAN card is converting from bits to bytes. That means converting from layer 1 information to layer 2 information. Then only we can see the source and destination MAC address. Then this device will check the destination MAC address is what? What is the destination MAC address? B. Yes, I am the B. Matching. Let me remove that one. That is called decapsulation. Who will do the decapsulation? Receiver will do. If first it will check the layer 2 information matching now. What next is what? Remaining information forward to the layer 3. And at layer 3, what the main job of the layer 3? Check the layer 3 information. What is the destination IP address? 1.2. That means, yes, that is for me. I am the 1.2. Matching. Remove that one. And remaining information will forward to layer 4. What is the layer 4 will do? It will check the layer 4 information, whether it is TCP or UDP. Yes, TCP. Because I am the F server. Okay. Who will carry that one? Only TCP only. Matching no? Yes. Remove that one. Then what will happen? Only HTTP will be there. Not HTTP actually. Here what will happen? No. I told already layer 4 will define the source and destination port number also. That means source port number is anything random written like a 2020. Destination port number is 80. It will be there here now. Source port number is what? Source coming from where? 20. Destination is 80. That means destination means I am the destination now. In my destination, in my device. Okay. What service they are asking? This guy is asking 80 now. 80 means 80 is related to HTTP. Okay, based on this port number only, device can understand this number is related to this protocol. Then by using this protocol, this device can open the web page or HTML code. Then we can see that HTML code here. Clear now? This is all about the process. Which process? Encapsulation and decapsulation. Without this encapsulation and decapsulation, we can't access any requirement. It could be web or mail or file. Okay. Now, who will do the encapsulation? Encapsulation will be done by this guy. Decapsulation, this guy. Source will do the encapsulation. Destination will do the decapsulation. Encapsulation means just adding layer 7, layer 4, layer 3, layer 2, then convert into bits. Decapsulation means remove the headers. First, remove the layer 2 header. Next, remove the layer 3. If it is matching. If it doesn't match, drop that one. Okay. Write down, please. Decapsulation will be done by the receiver. Let me pause the record. Yes, at layer 7, what is that? Data, guys. Where is the data here? This is called data, guys. This is your data. For the data, I am attaching layer 7 information. Then The data once it will come to the layer 4 will assign the layer 4 information that is called TCP and also source and destination port number. Source port and destination port number. And entirely that is nothing but a segment. Segment will be transferred to layer 3. Layer 3 will assign the layer 3 information. Then that is entirely nothing but a packet. That packet will be sent to the layer 2. Layer 2 will assign the layer 2 information with the help of layer 2 protocol that is called Ethernet. Then that is entirely nothing but a Ethernet frame. In the Ethernet frame, all the fields will be bytes only. That should be converted into bits by LAN card. Then cable will carry. Okay. Then what this guy will do? This guy first check the layer 2 information. First convert from bits to bytes. Check the layer 2 matching no remove. Check the layer 3 remove. Check the layer 4 TCP. Check the destination port number 80 related to HTTP. By using this, it can open the web page or else HTML code. Okay. Any question up here? No question. This is called encapsulation and decapsulation process. Okay. Now we'll see a difference between OSI and TCP IP model. See guys, OSI has been introduced by ISO in the year of 70. Okay, ISO means International Standardization for Organization. Okay, TCP IP model also one more model is there. That is implemented by DOD, Department of Defense. Okay, Department of Defense in the year of 83. Now, how it is working? Same like this only. See, before it was into this one only, no? Okay, based on this only they implemented what? TCP IP model. This is for real-time implementation purpose and this is for learning purpose. Okay, check it over there. First, go to the LAN cards, ncpa.cpl, enter. It will display LAN cards. Click on the any one LAN card. Let me click on this one. Right click and properties. Check it out there. Is there any OS properties? No, right? We have only TCP IP version 4 property and TCP IP version 6 property. That means which model is implemented in real time? TCP IP model. Okay. If you click on this one, if you click on the property, then we can define the parameters. What are those? If you click on the use the following IP address, then you have to define these things: IP, subnet mask, default gateway, preferred DNS, alternate. Clear? That means TCP IP model is implemented in real time. But how it is working? It is working same to OSI. Okay. Working to same like OSI. But how many layers will be there in the this TCP IP? There are 5 layers, not 4 layers. 5 layers. What are those? Combination of these 3 layers are nothing but here is application layer and transport is transport only. These names are before old CCNA. Now new CCNA same to same only. Transport layer and network is called what? Network layer only. Data link is layer is called what? Data link only. Physical is what? Physical layer only. Simply they combine these 3 layers into one layer that is called application layer. And this one is same to same transport only, network only, data link only, physical only. But how many layers will be there in the TCP IP? No, TCP IP. 5 layers. What about the OSA? 7 layers. Okay, this is for learning purpose or reference purpose. This is for implementation purpose. Okay, how many layers? 5 layers. Okay, now write down please. This I need to change. I will write down here TCP IP layers. Okay. Combination of these 3 layers are here is nothing but application. Transport is transport only. Network is network only. Data link is data link only. And physical is physical layer only. Yeah. Where is the remote? Yeah. Can you please turn up that one? That one only. That one. If you want, turn up this one also. Your wish, okay? Voila. Let me pause the record. Yeah. Now we need to discuss about the headers. How many headers are there? Layer 2 header, layer 3 header, layer 4 header. Let me start the recording also. Yes, going on. At layer 2 means it will header means what? Information. Ethernet means layer 2. Header means information. That means what the layer 2 information? MAC address only. Clear now? What is that? Source and destination MAC address. And layer 2 will carry upper layer information. That is called layer 3. That means IP address. In IP address, there are two versions should be there. Correct now? How many versions? Two versions. IP version 4 and IP version 6. Okay, we'll discuss what the difference. Okay, here is our version 4 as a type number. We have a protocol number for TCP UDP. Like for every version as a type number will be there. For this type number is 0x. I'm writing now type numbers 0x0800. For version 6 0x86DD. And one more also there above layer 2. What protocol? Address resolution protocol. That is a layer 2.5. For ARP, what is the type number? 0x0806. These type numbers you need to remember. Okay. For 800 for version 4 and 86DD for version 6 and 806 for simply remember 800 for version 4 and 806 for ARP. 806 for what? ARP. And remaining 86DD no, that version 6. 800 for version 4, 806 for ARP and 86DD for what is that? IP version 6. These numbers, okay? That means your layer 2 is carrying upper layer information. It could be version 4. See, all are works under, these two works under layer 3. Correct now? What about this guy? Layer 2. That means layer 2, layer 2.5. Layer 2 is carrying above layer information. Now, what is that? Layer 2.5 or layer 3. Clear now what it is carrying? That will be indicated with the help of type number. If your type number is 800, that means your layer 2 is carrying upper layer information. That is called what? 800 means version 6. Clear now? Same like that. Yeah, version 4, 800. Now, your layer 3, header means what? Information. What is his own information? IP now. Layer 3 own information is called IP address and also it is carrying upper layer. What is that? Layer 4. At layer 4, we have a TCP UDP. What is the protocol number for TCP? The protocol number is 6 means it is carrying TCP. Protocol number is 17 means it is carrying UDP. That you need to understand. Here type number means type number is 0x0800 means it's carrying IP version 4. Next is 0x0806 means address resolution protocol. 0x86DD means it is carrying version 6. This is very, very important. Type numbers. Okay. The type number is this. That means it is carrying version 4. But only one number will be there, not all numbers. Now here protocol number is 6 means your IP is carrying TCP. Protocol number is 17 means it's carrying UDP. Now layer 4 header. That means layer 4 information. At layer 4, what is TCP? No, layer 4 is called this, and it will carry source and destination port number. Okay, if the destination port number is 80, that means it is carrying layer 7 information is called HTTP. Correct now? The destination port number is like a 443. The destination port number is 53. No, this is not TCP, no, UDP, right? Yeah, next is 25. Next is 23. Telnet. Next is 22. SSH. Clear now? Based on the protocol, sorry, based on the port number only, we can able to tell TCP is carrying either HTTP or HTTPS or SMTP what. Clear now? No, right down please. This is all about what? Headers. How many headers are there? Layer 2, layer 3, layer 4. Okay. Now we need to discuss about the Ethernet standards. See, there are three Ethernet standards are there. One is called Ethernet 2 frame, one is called LLC frame, one is called snap frame. Okay. IEEE 802.3 LLC frame, IEEE 802.3 snap frame. Now, this frame, just now we discussed now, layer 2 frame, Ethernet frame. Okay. It consists of what? Its own information. What is that? Ethernet is a layer 2, right? It has a own information that is called source and destination MAC address. Correct? And also type number also now. Okay. Payload means data. For your data, you need to attach the source and destination MAC. Because of we are discussing about the Ethernet means layer 2. Layer 2 frame will define first MAC address for the data, and also it will define the type number to indicate whether you are carrying your layer 2 is carrying version 4 or version 6 or R protocol. Okay. Next, clear guys up here? These fields are clear. Any doubt? What are these numbers? Bytes. MAC address 6 bytes. Okay. What about the type number? 2 bytes. I written now 0x0800. X means what? Very good. Hexadecimal format. How many hexa numbers over there? 4. Each hexa number equal to how many binaries? 4 now. 0 equal to binary is what? 4 zeros now. That means 0 0 0 0. What about 8? 1 0 0 0. What about 0? How many zeros are there? 16 bits are there. That means how many bytes? 2 bytes. That only written here now. Clear now? Your data payload should be minimum 46 bytes, maximum 1500 bytes at layer 2. More than that, what will happen? Fragmentation. Okay, dividing into small. At layer 4 will do what? It will do the segmentation now. It will take the data dividing into small slices. That is called what? Segments. At layer 2, fragmentation. Now, clear all these fields up to here. Any question? This will discuss. This one and this one will discuss. In this 4, any doubt? No doubt? No, see, we are not discussing about these two things. That is will be NP level, okay? LLC and Snap will be NP level, okay? Only we are discussing Ethernet 2 frame. That one is called this. Now, preamble. See, I want to send the data from where to where. Source MAC address is A and destination MAC address what? B. This is called A. This is called what? B. I want to upload some data. Before uploading, I want to check. Yes, destination MAC address is available for my data. And also, type number is what? Version 4. Because of this is called what? IP address 1.1, 1.2 is what? IP version 4 address. Okay. And data also there. Which data you want to upload. Before sending the data, your cable is fine or not, we need to discuss. Correct now? If your cable is not working, this guy will receive the data? No, right? Who will check this cable is working or not? Preamble will check. Preamble will sync with the media. It will sync with the media. Are you fine or not? There is no issue with the cable. Then what will happen? This is what do you mean by this? 8 bytes. That means how many bits? 64 bits now. There is no issue with the cable. No, then we can able to see the bits will be 0101010101. There is issue with the cable, then you can see the middle continuous zeros and continuous ones. There is no issue with the cable means in the preamble field, all the bits will be 010101. In middle like a continuous zeros or continuous ones means there is some issue with the cable. Okay, there is an issue with the cable, hardware issue or software issue. Okay, that will be decided by this guy. Preamble will check your cable is working or not, or else it will sync with the media. Media means cable only. Okay, everything is fine. Continuously 010101010101 only. That means your cable will carry. Once it will come there, that Ethernet 2 frame, maybe some errors are there. How this guy will come to know errors are there or not in the data or in the Ethernet 2 frame? That will be identified by this guy. CRC is algorithm, cyclic redundancy check. Cyclic redundancy check is an algorithm. It will figure out whether any errors are there or not. How it will figure out? It will assign the some numbers at source guys and destination guys. For you, I'm assigning number is 123. For you, 123. Both are getting same numbers, now CRC numbers. That means he received Ethernet 2 frame, that is fine, no errors. Suppose here is 123, here is 173. That means there is some errors are there in the Ethernet 2 frame. Then what this guy will do? He will discard that Ethernet 2 frame. Whatever the data I received, he will discard. Discard means dropping. Clear now? This is all about the Ethernet 2 frame. These many fields will be there. I told no, Ethernet 2 frame, every field in the form of bytes. That is called this. That bytes your cable will not carry. That should be converted into bits done by this LAN card. Correct? No? That will be done by LAN card. Before converting into bits, okay, what will happen? All the fields we need to check. Who will check all these things? Your layer 2 protocol called Ethernet 2 is a layer 2 protocol. It will check all the fields are properly available or not. Yes, everything is available. Then take down this total information and over to LAN card. Then LAN card is converting all the bytes into bits. Then cable will carry. That is I told no bits. Every field should be converted into bits. Converted into bits. Okay. Now write down guys. Any question up to here?
Sir, for payload field, there will be a MTU mismatch or fragmentation is there in layer 2?
Not in layer 2. That will be in layer 4.
Layer 4, okay.
Yeah.
Shiva,
Yeah.
how is the type number determined, right? Like, is it dependent on the switches that you or the adapters that you have? We do not enter
How the bytes will be?
the type numbers.
Yeah, type number. See, for type number automatically, we have a field now, automatically it will calculated by your Ethernet 2 frame will be assigned one type number based on the which IP version is running at layer 3. In the layer 3, IP version 4 is running, then automatically what will happen? The type number will be 0x08 automatically will happen. For every version as a type
Correct.
numbers.
Correct.
For OR 806. Okay. Everything is automatically will happen, just we are learning, that's it. In the future, suppose this automatically nothing is happening, there is some issue will happen, then we need to troubleshoot. If you know all these things, if you don't know, then how you can troubleshoot? Correct?
Correct. So is there a chance that the source and destination will have two different types of versions of IP4 and IPv6?
That will be advanced level, NP level. There is some translation will happen, but
Okay.
this is see version 4 and version 6. It's not possible actually within the LAN. I'm discussing about what Ethernet. No, Ethernet means
Correct.
L2 means within the LAN. How it is possible? Not possible.
Okay.
Between the LANs, no. Suppose in my LAN, I have a version 4 address. My internet is totally working with the version 6. That time we need a translation between version 4 to version 6. But within the network, not possible. Two devices are having the different versions.
Yeah.
Not
Okay.
good. Okay.
Got it. Thank you.
Thank you. Let me pause there. If you have a lots of money, what you will do? You will not learn anything. Clear now? If you have a 10 crores are there. Why you come here? You will become lazy. Any use with you? Because of you, any use for the world? No use. You only living, that's all. No use. Okay, that is not good. Okay, you need to gain something, you need to share something. You have to gain the knowledge, you have to uh, work for the company. Then if you work for the company, then you can give the support for the customers. Okay, if any issue will come, you can able to resolve. That is a life. Okay, that's why. Okay, don't download everything. Okay, right guys, and now we need to discuss about the this one. This is also done, right? I think almost is done. Almost is done. Now we have headers are there. Headers. Okay, that we'll see tomorrow. Okay, tomorrow is Friday, no? Okay, as for our day 4, what is the content? Day 4, I forget that. The oh, one second. Where I downloaded that one? Desktop, no? No, not desktop. Here only. Yeah, this one.
Sir, day 4 TCP OSI TCP IP model part 2, sir.
Okay. Part 2.
And introduction to Wireshark.
Yeah. Today is what? Day 3, no? That means from Tuesday onwards.
Oh,
Okay, day 3,
okay,
this
sir.
one
Okay.
only. This will be
Part 1
tomorrow.
only. Yes.
Okay, headers. Header also we done. Now we will discuss about the complete detailed headers of IP, TCP, or GR. See there is one more RP is there, guys. What is this RP? GRP is there. Okay, proxy RP is there. Okay, ARP to figure out destination MAC address. To figure out, it will figure destination MAC with the help of destination IP. What about this GR will do? It will figure out duplication IP. In the LAN. That means there are 2 PCs are there. Okay, at 2 or 3 PCs. Okay, connected with the switch, guys. Recording is going on. Yeah, connected with the switch now. Now for this guy, IP address is 1.1, 1.2, 1.3. I want to assign the IP address 1.1 again. If you try to assign, if you give the enter, what will happen? You will get the message now. This already used by LAN users. How you are getting that message? Because the background protocol is GR. Grace CSR. If you assign any IP address, automatically what will happen? This guy will ask to everybody. This guy will ask to everybody. My address is, I want to assign this one. My MAC address is A. Okay. Anybody is having this address. Anybody means I need to ask to everybody. When switch will ask to everybody? The destination MAC address is. In which scenario switch will forward to everybody? Yeah, the broadcast, no? That means source IP 1.1, destination IP also 1.1. Source MAC address is my MAC address. Okay, I want to ask to everybody. When switch will ask to everybody? The destination MAC address is broadcast. Next is opcode number, no? Okay, what is the opcode number for the ARP? In the ARP now, what are the fields will be there? Source IP.
Destination IP. Source.
Okay, source MAC address, destination IP, destination MAC address. Next is what? Opcode, no? What is the opcode number for request? 0x0001. What about opcode number here? Here also opcode will be there. That is called 0x2. 0x2. No 000. That means if opcode number is this, means that devices will understand, oh, I received the GR. That means somebody is asking about anybody is having this address. No, that is not my address. You will discard. You will also discard. Correct now? They are not one dot. He is a 1 dot. What this guy will do? Yes, my address is 1.1. I will give the reply packet. Once he will get the reply means he could not assign this address. Suppose he is not getting reply within 30 milliseconds. That means he can able to assign this address. G or reply will come within 30 milliseconds. Then only you will come to know. You will generate the one message that is called this address is already used by so and so PC. If you're not getting that message means nobody is having that information, that IP address. Then we can able to, this guy will take this IP address. Clear now without any errors. That means here will do what? It will figure out the duplication IP address in the LAN. Next, proxy RPZ. This will be, we will discuss about in static routing. Static. In the routing, no, static routing is there, default is there, dynamic is there. There we'll discuss, okay, in static routing. Just now we discuss ICMP also done now. Unicast done, broadcast done, unknown unicast also done. Yesterday, who is asking about this question? Online, no? Ari, I think. Who is asking? Ari, I think. Ari or Dipin. Clear unknown unicast also done. Which scenarios which will do unknown unicast? What do you mean by unknown unicast?
So when switch don't have any, then
Yeah.
when those
But PC sending the unicast. Okay, that means PC sending the unicast. That means source address is A is there, destination is B is there. But what switch is telling? I don't know about the B MAC address. In my MAC table, that entry is not there. For me, that is unknown. I don't have entry B MAC address. What I will do? I will forward to all the ports. That is called unknown unicast. We have an entry in the ARP table, but we don't have an entry in the MAC table. That time, switch will do unknown unicast. That is called broadcast only. The switch will receive the ARP request. That is also broadcast. Okay, this is part 1. Right, guys. Now, headers we'll discuss now. Just basic header is done. IP, TCP, or ZR header done. Okay. In the ZR, what is the header? Source IP 1.1, MAC address A, destination IP 1.1, MAC address broadcast. Opcode number 0x2. This is all about the header for ZR. Header for ZR. Source IP, source MAC, destination IP, destination MAC. Source and destination IP will be same. Clear now? My MAC address is this. I want to ask to everybody. Anybody is having this address. That's why destination also same IP address. Clear now? Next UDP header we'll discuss. Now we'll do one thing. We'll open the Wireshark tool. Okay, we will finish today itself all these things. Okay, we'll finish today itself. Okay, and others will do one thing. Yesterday I discussed about the ping process. Now that I will explain, and remaining these things we'll see tomorrow by using Wireshark tool. Okay, did I explain about the ping process by using packet tracer? No, right? Yeah, that I will explain now. Once it is done, then we'll stop the class today. Then tomorrow, this one. Then introduction to IP address. Introduction to IP address. Let me design the topology now. Close all these things. Packet tracer. See guys, I given the introduction for packet tracer day first. Okay, day 1. Okay. Now what I will do, I will take the PCs. Click on the end devices. Take the PCs. Click on the laptops. Take some PCs. 4 PCs. Then connect all these PCs to the switch now. To the switch. Click on the network devices. Click on the switches. Take the any switch. Then click on the how to connect. Click on the connections now. Connections. Click on the automatic. Now what we'll do, we'll increase the font, topology font. Now, what I will do, I will give the IP address for this guy 1.1.1.1 and MAC address will be, I will give a for our understanding purpose. Actually, nobody will change the MAC address. This is for our understanding purpose. IP address for this guy 1.2 and MAC address will be B, I will give. And for this guy 1.1.1.3 and MAC address will be C. And for this guy 1.4 D MAC address. Clear? Now what I will do, I will assign the IP address. How to assign the IP address? Click on this guy. See, this cable is connected on LAN card. Okay, LAN card as a port, LAN port, no? That is called fast Ethernet port. FM is fast Ethernet. There are types of Ethernets. Types of first one is called Ethernet port. Second one is called fast Ethernet port and gig Ethernet port or 10 gig Ethernet port. For Ethernet port capability, it can able to send and receive at the speed of 10 Mbps only. Fast Ethernet 100 Mbps and this guy 1000 Mbps or 1 Gbps. 1000 Mbps or 1 Gbps. What about this guy? 10,000 Mbps or 10 Gbps. Clear na? This is all about the difference. But we have what port is available here? We have a port called fast Ethernet port. That is a LAN port. For that port, what IP address we need to assign? This IP address. What MAC address? This MAC address. Okay. Let me do that one. Click on the config. First click on the laptop and click on the config. We have port now. Fast Ethernet 0. So and so MAC address is there. IP address is nothing is there. I will change the MAC address to last 4 EXA numbers to A. IP address will be 1.1. What is this? Don't worry, we will discuss in the IP address. Okay. And what about this guy? MAC address will be B 1.1.1.2. I will give. Okay. For this guy 3, MAC address is C 1.1.1.3. And for this guy, MAC address is D. IP address will be 4. Done, right? Now we need to see the packet flow. Check it over there. Click on the switch. Click on the CLI. Okay. Now I will check the MAC table. Okay. Show MAC address table. Initially, these entries will be gone, guys. No entries will be there. Okay. Here packet tracer now it will display. When switch will learn the MAC address, if the switch will receive the ARP request, that time only. Okay. Switch will receive the ARP request. The switch is not received anything, it will not learn. Clear ARP cache. We'll discuss this one later. Don't worry. Okay. Like this. Initially, what will happen? Your MAC table, how to check? Show MAC address table. This is a command. Any entries are there? No entries. For PC will maintain what table? ARP table now. Click on the desktop. Click on the command prompt and check the ARP table. How to check? Any entries are there? No entries. That means ICMP packet will go if you give the ping command? No. Because of I don't know about the destination IP address. I know. I don't know destination MAC address. Okay. Now what I will do, I will ping from here to here. Okay, I will ping from here to here. How to ping? ping space 1.1.1.2. Don't give the enter because I want to see which packet is dropping, which packet is going. How to check that one? Click on the, there are two modes are there here. If you want to see the packet flow, PDUs, you need to click on the simulation mode. Then all protocols are by default enabled. I don't want to see the packet flow for all. I want to see the packet flow only for the ARP and ICMP. Let me disable all these things. Click on the none. Then select the specific protocols by click on the edit filter. Now select the ARP and ICMP, close. Getting now only two. Now we need to give the enter here. Check it over there. Initially what will happen? ICMP date. Because of layer 2 information is missing. Destination MAC address is missing. He is telling what? I don't have layer 2 information. I have layer 2. Sorry, layer 3. I don't have any layer 3. Clear now? I told now how many PDUs are there? Layer 2, layer 3 and ICMP header also one PDU. Now layer 2 PDU is called what? Ethernet 2 frame. What about the layer 3? IP packet, layer 4 TCP and TCP. We have ICMP segment also, ICMP header also. But check it over there. Click on the outbound PDU detail. See there. Directly IP header is there. Before IP header, what header is required? Layer 2 header, no, Ethernet header is required. Is there? Ethernet header is missing, guys. Check it over there. This is called which header?
Right.
This is completely IP header. This complete box is called what? IP header. This complete box is called what? IP header. Let me decrease this one. This complete box is called what? IP header. Before IP, there is a layer 2 box is required. Now, where is the layer 2 header? Missing because of this ICMP telling I don't have idea about the layer 2. Okay. We have a ICMP header also. Check it over there. ICMP header. Can you see here type and code? No. See now? Can you see here IP is carrying about the protocol number? Protocol number is 1. That means it is carrying ICMP. Okay. And before that, we need a layer 2 box is required now. That is called Ethernet box. What are the fields will be there in Ethernet box? No. Preamble, source MAC, destination MAC, type number, payload, and CRC. Where is this box? This box is totally missing now. Because of layer 2 information is missing. Clear now? Who will figure out the layer 2 information? Our protocol. Yeah, now tell me guys, this consists of what? ARP no, ARP request no, ARP request. Tell me what are the fields will be there? Yeah, what are the source IP? MAC address, destination IP, MAC address, B. F guys, broadcast. What are the opcode number? Clear now? This information will be there. Clear now? Check it now. Check it over there. Source IP 1.1, destination IP 1.2, source MAC address A, destination MAC address F. Where is the opcode number? Click on the PDU details. Click on the outbound PDU details. Okay. Now you can see the opcode number under ARP box. This is called ARP box. This is called what? ARP box. This is complete. Here we can see the opcode number. Clear now? Here we can see the opcode number. This is complete in nothing but a layer 2 box. In the layer 2 box, destination MAC address is this. In the ARP box, destination MAC address is this. This is the interview question. What is the destination MAC address in the Ethernet frame and in the ARP frame? Sorry, ARP header. In the Ethernet header, destination MAC address is this, and ARP header, what is the destination MAC address? All, sorry. Let me 1 minute. Yeah. In the Ethernet frame, what is the destination MAC address? F. What about the ARP header? All zeros. And switch will follow this header or this header. Switch will check the ARP header or Ethernet header. Switch is a which layer device? But it is called which layer? It is called which layer?
2.5.
Switch will understand which layer? 2 only. That means switch will check only this box only, not this box. Clear now? Now switch will check the this box. Destination MAC address is this. That means I need to forward to everybody. Okay, if the switch is following this one, what will happen? Destination MAC address 0. That means what? Nothing. Clear now? This is an important question, guys. In interview, they will ask, what is the destination MAC address in Ethernet header and in the ARP header? In Ethernet header, all F. In the ARP header, all 0. When you can able to tell this answer, if you can able to open all the packets, you need to check all the fields. Okay, opcode number we will see in the ARP box. Okay, clear, guys? Any question? Source IP 1.1, destination IP 1.2. Source MAC address is what? A, destination is I don't know, FF. Clear now? See there, we have a type number. What is that? 806. That means your IP is carrying, sorry, your Ethernet is layer 2 is carrying layer 2.5 information. That is called ARP. That means layer 2 is carrying ARP. How you are telling? Based on the type number. Based on the type number and layer 2. Okay. And we have a data is there. We have a preamble. We have a FCS. Okay. Right. Now let me forward this broadcast packet. And the switch will do what? It will learn the source MAC address. Check it over there. Before no entries now. Now it is learning. It is learning source MAC address. Then it will check the destination MAC address. It will check the destination MAC address. Check it over there. Is it received on the port number 1? Na? It will send on the port number 2, 3, 4. In means just no received. Out means I want to send. I want to forward to all the ports. Because of destination MAC address is broadcast. Forward to all the guys and these guys will discard. Why they will discard? Because they are not 1.2. Okay. He is a 1.2. And he will check the source IP source MAC address and opcode number. The source IP MAC address he will learn in the which table? ARP table. And he will send the ARP reply. In that he will mention his own MAC address, IP address and destination IP address MAC address. Okay. What are the information will be there here? Yeah, this is ARP reply now. Reply packet will go now. Yeah. Reply from where to where? 1.2 to? Yeah, 1.2 MAC address is what? B. 1.1 MAC address what? A. Opcode number? 2. This information will be there. Okay. Check it now. Yeah. Outbound I want to check. Outbound means I want to send the reply packet. ARP reply. Reply from where to where? Reply from 1.2. Check it over there. 1.2 to 1.1. Na? 1.2 MAC address B. 1.1 A. This is opcode number is what? 2 now. Where I can see this opcode number? Open the outbound PDU details. Check it over there. Opcode number is this. At layer 2, it will assign the source and destination MAC address. Source MAC address B. Destination is A. Source is what now? 1.2. MAC address what? B. Destination 1.1. MAC address what? A. Now, this is source and destination entries are present. Then switch will do what? Unicast or broadcast?
Unicast.
Both the entries are present means switch will do unicast only. Switch will do unicast only. See. Now switch will learn the B MAC address also. Check it over there. Before only A MAC address, now it is learning B also. See. And it will check the destination is A. Available on which port? Port number 1. Sending from port number 2 to port number 1 only. Now he receive the ARP reply. Now you will come to know destination MAC address is B. Take that MAC address, add in the ICMP header. Now see in ICMP, first initially it is telling layer 2 information, I don't know. Now it is telling, yes, I know the layer 2 information. Source is mine, destination is B. Now I can take the destination MAC address. I can able to build the layer 2 PDU. That is called what? Ethernet 2 box. Ethernet 2 frame. You can check it over there. Outbound PDU. Is there a layer 2 box? But here any layer 2 box is there? Check it over there. Here, this is called this box. Let me put like this, okay? Small one only. Let me open this also. For two, we can't open at a time. Okay, that is a problem. Okay, no problem. PDU. See guys, this is called this information. First one. Any Ethernet to box is there? No. What about here? Ethernet to box is there. Clear now? Without creating that headers, that packets will be dropped actually. They have to create the layer 2 box, layer 3 box, and remaining all the boxes. Okay, this is a layer 2 box. Okay, now this is called ICMP request. Now ICMP request will be always from where to where? Request will be always from 1.1 to 1.2, 1.1 MAC address A, 1.2 MAC address B, and the protocol number 1 now. Type number what? 8, code number 0. Okay, this information we can see at this box, and this information we can see at this box, and also protocol number also we can see in this box only. This is here. And where I can see this type number and code number? One more box, that is called ICMP box, or else ICMP header. Check it over there. ICMP header is it down? Type number and code number. Okay, let me forward this ICMP request. Then switch will check the destination MAC address B now. It is sending via port number 2 only. Unicast. Now you will forward the ICMP reply box. Reply from where to where? Reply from 1.2 to 1.1. 1.2 to 1.1. 1.2 MAC address B, 1.1 A. Now for ICMP reply, what is the type and code? 00 now. Okay, right. Forward this unicast. Now we can see the reply from so and so. What is this TTL? Time to leave. See, now write down the TTL values. I will explain the TTL value tomorrow. Only write down now what are the TTL values if you ping from the Linux. From Linux PC, TTL value will be start from 64. Okay, from Windows starting from 128. From routers means iOS 255. This is all about the TTL values. Write down please. TTL value. Okay, and now itself I will explain this one. Okay, see, this is my PC. This is my PC. Both are connected to the switch. Okay, one scenario. IP address will be. Let me start the recording also. Right. Yeah, and this guy, MAC address is A, and this guy is B. IP address 1.1, IP address 1.2. Okay, if you ping from here to here, both are in same network or different network? Same network, no? Then you will get the TTL value will be 128 only. Now, one more scenario. Let me take one router here. Why router is required? To connect one more network. To connect what? One more network. Let me take one more network here. Switch. Then from there to 2 pieces. And from here to router to this switch again. And these PCs are belong to MAC address will be C and D. And this IP address will be different IP address 2.1, 2.2. Now, if you ping from here to here, you will get the TTL value will be if you are pinging with the same network, you will get the TTL value 128. If you ping from one network to another network, means different network, TTL value will be changed. Okay. If you pinging now, what will happen? Ping from here to 2.1. You will get the replay. Okay, you will get the replay. That means 2 dot is available where? 2 dot is both are in same network. I am 1 dot. My neighbor is 2 dot. Both are different. Different networks will be communicated by with the help of which router? Sir, which device? Router. That means both are different network. No. That means I need to forward the packet to router. Who will forward the packet from one network to another network? That is a job by router. That means I need to forward the packet to the router. Okay, if forwarded. Then router will do what? Router will switch the packet from this interface to this interface and it will send and reply will come. That means we are crossing our route network. No? Once you cross to your network, if you go for another network, you are coming from that network to this network. That means middle how many routers are there? One router. Correct now? One router. That means what will happen? That router will decrement the TTL value. Okay, router will, that means the TTL value will tell what? If you give the ping with the 2.1, you will get the TTL value will be 127. That means from source to destination, there is one router is there. One more router is there, then what will happen? It will decrement, this will decrement by 1, 128 minus 1. You will get the 127. What about this router will do? 127 minus 1, you will get the 126. That means before, sorry, source to destination, how many routers are there? 2 routers are there. Whereas 2 networks we need to jump, then only we can reach the particular destination. Clear now? We can able to reach to the particular destination. Now let me ping from here to google.com. Correct now? Then you will get the TTL value is what? 128 are different. Different mandatory. Because we need to crash our network, then reach to the wireless router from there to google.com server. Maybe how many routers are there that we don't know. That we will come to know by seeing this number only. Maybe you will get the 120. TTL value is what? 120. That means from here to that google.com server, how many routers will be there? 8. That means 120. 8 minus 120. What you will get? 8 now. That means 8 routers are there. Every router is decremented 1 TTL value. Let me check that also now. Open the command prompt. It's already open. No, no, it's not open. Yeah, it's open here. Yeah, okay. Ping with the google.com dot google.com. Check it over there. You're getting TTL value 116. That means how many hours away your server is available? 12. Clear na? 128 minus 116. You will get the one number. That means that many routers you need to crash to reach a particular destination. Clear na? That is all about the TTL field. Where we can see the TTL field? In the layer 2 box or layer 3 box? Layer 2 or layer 3? Very good, very good. Layer 3. Check it over there. This is a layer 3 only. Check it over the TTL layer 3 box. Clear na? Layer 3 box. Okay. Clear guys, this is all about the ping process done. Now you need to install the Cisco packet tracer and design the topology like that. Okay, you can practice this one. Okay. Any question online guys so far?
No, sir.
No question?
No.
Right. Okay guys, we'll see tomorrow. Take care. I will share this recorded section as soon as possible. Okay. Maybe 12 o'clock or 1 o'clock. Okay.
So now switch will have already the
Yeah.
but 1.3 is not the
Yeah. It's not, this entry is not there here.
so in that case it's not the still
No. Here you want to send the data from where to where?
1.3 to
1.3, sorry. 1.3 to 1.1 now. Okay, you want to send some data. Okay, what is the source IP? 1.3 MAC address C, and what is the destination IP? Initially you don't know. Destination is 1.1 MAC address you don't know. What will happen? It will come there, sending to all the guys. Only this guy will receive and remaining guys discard. Broadcast only. Switch knows about 1.1 MAC address. But switch will understand this address? Layer 3 address? No, layer 2 address only switch will understand. Okay, even though at layer 3, this is unicast, I will understand. Layer 3 unicast. But layer 2 broadcast. Switch will check only layer 2 information only, not layer 3. Layer 3 means IP, layer 2 means MAC address.
So, sir, we can say like that, na, with the help of our table entries, which will understand the where traffic will go. Like it can come to know where destination MAC address will
Yeah.
correct?
In this scenario, this packet will never travel. In this scenario, ARP request and ARP reply. Request will be 1.3 to 1.1. Na? Then reply will be 1.1 to 1.3. Then only this data will go.
Yes. Okay, sir. Thank you.
Thank you. Okay, guys, take care. See you tomorrow. Okay. Thank you.
Thank you.
Thank you, guys.